Hello everyone, I'm Iona Lin and this is my AESD final project demo. So for the final project, I have implemented an I2C interface to the LSM90S1 accelerometer, which will initialize the bus, read and write its control and data register so that it can collect the data from the sensor at runtime. I've also done the GPIO communication using the push button as input and LED as output. So with respect to the initial plan, I have done the I2C communication and the GPIO input output communication, and the AESD device driver and the demo application will be done as a future work. So for the demo, I had to use build root to do the customized image on the RPi hardware. So for the build root repo, I had to add a package which will help me to create a customized image, that is using I2C and GPIO. So here I've used GPIO library. So for that, the code is written in the application repo. So in the application repo, using the code reference taken from here, I have customized it so that it would open the chip to access the GPIO handle. And once that is done, I can declare two pins, one as output and another one as input, so that I can request for events on rising edge, and I can trigger the LED on state once the input is detected. So after this, I worked on the I2C. So here I had to open the I2C using the addresses, and once that was done, I had to detect the sensor identity addresses to check if I can start the communication. So once that was done, I configured the accelerometer, gyroscope and magnetometer such that the accelerometer and gyroscope would run at like 119 hertz and magnetometer at 80 hertz. So once the configurations were done, I read the data 6 bytes each from each of the components and printed them out. So once that was done, I tested both and it will be included in the demo. I've also written code for the character driver where in the accelerometer repo. So here if you see my code, I have done the interrupt and I have used the previous driver code to access the read from the sensor, and as per the initial plan, I have also implemented the map and ioctl, which will not be demoed, including the demo app where I have written a simple program so that it can open the node and it would read the data and print it out on the terminal. This is my demo. I've used RPi model 4B along with LSM90 S1 sensor with GPIO, button logic and LED implemented. I've loaded the customized image onto my RPi and I have logged in via root. So here you can see that my I2C and my GPIO LSMDT test have been installed onto my target. So now I can use those code section to run my sensor test. So starting with the I2C, you can see that the I2C has successfully picked the data from the sensor, and I can change the axis and see the data change. So you can check for all axes and you get the real-time data. The same thing along with the GPIO. So I can run the GPIO test, and right now it is monitoring the GPIO pin and waiting for the input to toggle the LED. So if I press the button, it detects the press and ons the LED, and I can off it the same way. This is my demo. Thank you. The challenges that I faced during the project were mainly I had initially planned on using BMA 400 sensor, which was not giving me reliable communication values back when I was interacting with it. And this took up a lot of my time to realize that this inconsistent value would not fare well in the long run. So I changed the sensor to LSM90 S1 sensor. The other issue I faced was when I was implementing the character driver, my build root environment kept crashing, causing my Ubuntu to fail, and my VirtualBox was not accessible. This problem took up a lot of time since I was clearing this issue and triggering the build and solving the problem, and I would still have the problem. So this stopped my implementation and further implementation. The lessons that I learned were mainly how to use the build root in a more day-to-day environment when using any kind of sensor, interfacing with, let's say, in my case, I've taken RPi. So I could automate cross compilation and I could do root file system generation and kernel configuration, which was a little bit in an extended way from what I had done in the class. I also learned how to work with libraries for the GPIO and the I2C where I had to use the Linux I2C.